I'm back. I'm about to do the distance formula. That is the distance formula. A lot of times, you know the formula, you know how to plug and chug, but you just don't know where it came from. So what I'm going to do is go over the origin of the distance formula. Where did this come from? Who came up with it? Craziness. Actually, I'm going to connect it to something that you already know. When we're talking about right triangles and we want to know a side that's missing, what's the theorem that you usually use? You're right, the Pythagorean theorem. Okay, so what we're going to do is connect the Pythagorean theorem to the distance formula. Hopefully, it brings it all home for you and it makes a lot of sense, okay? So, when we're talking about distance, we're talking about the distance between 2 points, okay? Let's say we get this point and this point. And we want to know how long the line segment is, or what's the distance from this point to this point. So first things first, we need to know where these points are. This point is at x1, y1. This point is at x2, y2. Okay? And I noticed that I can make some dashed dotted lines and connect them. And what does that make? You're right, a right triangle. So that's when we can use our Pythagorean theorem. Now let's fill it in. The legs of the Pythagorean theorem are both A and B. The hypotenuse of the right triangle is called C. Okay? We like to call it C. So let's write down Pythagorean theorem as you remember it. A squared plus B squared equals C squared. Remember that? Cool. So here we know A and we know B. I know y'all like thinking, Ms. Taylor, no we don't. But yes we do. Watch this. The distance from the origin to y2 is all of this. y2. Right? So let's say y2 is 8. This would be 8 units long. Right? So it's y2. y1 represents this distance. So if we take the whole black piece, subtract the red piece, then we end up with this piece. Oh my goodness, that's how long A is. So again, I'm going to say that one more time. If you take y2, subtract y1, you end up with the segment that's A. So A is now represented as y2 minus y1. Now you know what I'm going to ask you. How do you find B? Okay, I'm glad you asked. x2 minus x1, minus this part of it, that gives me the segment for B. Okay? So I can rewrite B as now x2 minus x1. Okay? And so I love to say plug and chug. Plug and chug. So that's what we're going to do. For A, we're going to plug in y2 minus y1 squared. And then for B, it's now x2 minus x1, and it's squared. Okay? And that all equals our C squared. C squared. Okay? Now remember in the Pythagorean theorem, you don't want to find C squared. You want to just find C. So we need to undo the square. Take it back. I'm just kidding. So we need to take it back and bring out the square so we just have C. How do you undo a square? You're right, the square root. The square root is the inverse function. It undoes the squaring effect. So here we go. We'll take the square root of both sides. Remember, with the equation, these are like baby twins. You got your two little sisters. You give one some candy, you better give the other one some candy or we're going to have some fighting going on. So when we square one side, or we take the square root of one side, we must take the square root of the other side. And we're left with the square root of y2 minus y1 squared plus x2 minus x1 squared. And that all equals C. That's awesome. And that's what we're trying to find. The distance from this point to this point, okay? So this is the origin and the foundation of the distance formula. Hopefully you got it. If you didn't, stop, rewind. Duh.